this short lecture examines the instructions or guidelines that the editors of scientific journals give to peer reviewers. And we focus in particular on scientific journals in the field of management. In this way, we will get an understanding also of what are the criteria that authors have to bear in mind when writing a scientific article, because these will be the criteria considered often by reviewers themselves. The lesson is divided in two parts. In the first part, introduce you to the functioning and role of peer review in the scientific publishing system, as well as its main challenges and the research to overcome such challenges. In the second part, we zoom in on the reviewer's guidelines as one of the instruments to steer and mold peer review, looking in particular at the differences in the instructions that editors of high and low-ranked journals give to reviewers. So this slide briefly illustrates the main phases and functioning of peer review. Peer review is the process through which scientific journals select scientific contributions, but it's also the process by which research funding agencies select scientific proposals. So once authors, scientists have written an article, they have to search for an appropriate venue, a journal that can be interested in their work, in their topic, and that has a good reputation, so that their work will obtain some visibility. The journal editor is often the first major entry point or steps for a manuscript, and the editors can make several decisions. One of these is to so-called desk reject the article and send back to the authors. Another option is to send to the reviewers, and here the peer review process happens. So the reviewers will send their comments to the journal editors. The editors might reject the manuscript at that point, or might send the manuscript to be revised to the authors. And eventually this process can repeat sometimes and lead into the acceptance of the manuscript. Now, peer review is now adopted by nearly all academic outlets as the legitimate way to select scientific contributions. So it is a central institution in modern science, and at the same time it is at the heart of bibliometric studies, because it is the process which leads to publications and eventually citations, which are the object of scientometrics and bibliometric studies. So why and how did peer review become so important in science? The most common and widely diffused story about peer review origins credits the 17th century philosophical transactions of the Royal Society as the first outlets to adopt peer review. But this creates the impression that peer review has been an unchanging part of science for at least 3 centuries, while in reality the institutionalizations of peer review has happened much later, in the course of the second half of the 20th century. For a long time, editors were basically the only managers of the peer review process. They analyzed themselves the manuscript and decided on their outcome. But with the increasing in size of science and specialization, they required the support of experts or peer reviewers increasingly over time, until today. So let's consider what are some major objectives of peer review. We can look at this question from two perspectives. The first is to look at how peer reviewers are expected to act. Namely, peer review perform two major functions of gatekeeping and developmental. Evaluation or gatekeeping is the core of peer review. Authors try to make a robust, important knowledge claim, while reviewers attempt to weaken it, to scrutinize for errors, assess the importance, inconsistencies in an argument, and in some cases scientific misconduct. But more recently, a new approach to peer review has been described, according to which reviewers also serve developmental functions by providing suggestions for improving a manuscript. So both the gatekeeping and developmental functions may have actually downsides. Excessive gatekeeping may result in rejecting valuable contributions by stressing, for example, the limitations of a manuscript. While on the other side, a developmental approach may violate authorial voice by affecting excessively a manuscript to the extent that it does not represent anymore the author's style, intentions, and goals. Another perspective is to look at what peer review examines. Either with a gatekeeping or a developmental approach, peer review is expected to focus on whether the knowledge claim in a manuscript are valid, namely they are true or supported sufficiently, and whether they are novel and important. And finally, also whether it is expressed in a clear and understandable way. Validity and novelty are the two most important aspects of a manuscript, because the legitimacy and reputation in science are fundamentally related to making and publishing valid and novel important knowledge claims. So the conditio sine qua non for validity is that research is conducted ethically. We see in the left side, if research is conducted unethically, for example by manipulating data, it will result in no validity and in illegitimate manuscript. Moderate and strong level of validity and novelty increase the prestige of the publication. And finally, on the top right corner, we find manuscript with very important scientific claims, which are also supported by strong conceptual and empirical evidence. Now examine some of the current challenges of peer review, some of its limitations. We have to stress that research on peer review has been growing in the last 10 years following studies that showed that peer review has some limitations and some problems. So let's examine some of these areas of research and problems at the same time. A first major challenge is related to the scientific production, which has increased dramatically over the last decades. We have now, for example, 2.5 million new scientific papers published each year and over 30,000 scientific journals. So peer review, we have to remind, is not a paid activity. scientists do that for free. It's a pastoral, voluntary activity. But since the scientific and higher education context has become increasingly competitive and scientists are under pressure to do basically everything, the problem is who has time to do a voluntary activity. So increasingly editors find difficult to identify reviewers. So scientists studying peer review are exploring potentially new incentives to enter into peer review, to accept to become a peer reviewer. For example, monetary rewards, giving some money to reviewers, but also non-monetary rewards like awards, recognition, certificates of peer review. But these measures might have also unintended effects. In particular, the so-called crowding out of intrinsic motivation. Reviewers accept to peer review a manuscript because they like it, because they find it intrinsically motivated, and providing an external rewards tend to crowd out these kind of motivation. So some research suggests or has found that either one that pay the reviewers enough, or it's better to not pay them at all. But this is still an open field of research, of course. Another major issue regards the very low level of agreement among reviewers, and this happens both for scientific articles peer review and scientific proposal in the context of project funding. This problem has been also designed and named as the luck of the reviewer draw, meaning that the selection, the randomly selection of reviewers, partly random, has a major impact on the faith of a manuscript. It is also very difficult to assess the novelty and importance of scientific contributions. Typically, this problem is exacerbated when it is necessary to distinguish good from very good contributions. For example, a study examined elite medical journals and found that the most impactful works are very often rejected. So they are initially rejected, published elsewhere, and display a very high impact, a higher impact than the papers already published in the journal. In another study examining scientific conferences in computer sciences, it was found that the more the conference is selective, the more it has an impact on average of their articles, but this is not true for very selective conference with an acceptance rate beneath 15%, which tend to have a lower scientific impact than conferences with a 15-20% acceptance rate. It also has, peer review, strong limitations in terms of assessing the validity. This is partly due to how the practice of peer review is established, which does not require to share, for example, the data that led to produce certain results. So as an outcome, replicability of the results is often impossible. It's very difficult to assess sometimes the validity of a knowledge claim. So trust typically has played a very important role. But again, in an era of super competition and there are strong incentives to cut the corners. And we have observed an increase, for example, in retractions and very important scientific scandals. The fifth issue regards the fairness. There is evidence when peer review is single blind, namely that the reviewers know the identity of the authors. We have evidence of bias in terms of gender, nationality, the language, bias against authors from peripheral institutions and from newcomers. So apparently double blind may overcome in part this problem, but again it's not always 100% effective, as reviewers might find other ways to know the identity of the authors. Peer review is also increasingly costly. There is an issue of efficiency, and this is also true for selecting proposals. It is a very consuming and costly activity on both sides of the authors and the reviewers. A recent study, for example, found that millions of hours are lost, so-called, in peer review, although peer review contribute to improving the manuscript. So to summarize, we highlighted some of the challenges of peer review, which led to a strong increase in interest and research on this topic. There are lots of interesting questions ahead. Now move to the second part of the lesson, where we examine the journal instructions to reviewers, also known as reviewer guidelines. What are reviewer guidelines physically? How do they look like? They are instructions to the peer reviewers on how to perform a peer review. Here we have an example in the form of a text, while other peer review have another format, namely as a form which asks very precisely and in detailed way which kind of criteria should be considered and what scale to use to assess the value of the contribution. So why is it interesting to study reviewer guidelines? Basically because there is a research gap in our understanding of peer review. So far studies have adopted either a very general point of view on the functioning of peer review, so a macro perspective, comparing different models, for example, or a micro perspective, focusing on the relationship and interaction between editors, authors, and reviewers, which are dependent on the very specific situation. So what is missing at the moment in this reconstruction is the meso-level, the middle level of the journals. So the question is, how do journals, editorial boards, editors try to shape peer review? They can try to address some of the limitations, or they might have very different needs, and therefore they can try through the instructions to shape peer review in a way that is consistent with their needs. So, how do journals instruct peer review? We see the position of the reviewer guidelines in the whole reviewing process. We have to bear in mind that scientific journals operate in a competitive, very competitive context. They strive for the attention and approval of the scientific community, and it is therefore crucial to publish important, valuable contribution, valuable manuscript. And editors and reviewers enact several controls and decision that should guarantee that the article is potentially suitable for the journal, that the reviewer can evaluate the manuscript and has an interest in doing that. Each actor in the review process try to optimize certain decisions. So, for example, top authors will try to publish into top journals when they believe they have a top article. And editors will try to have higher chances to recruit a top scientist as a reviewer. So this process subtly have an effect to align and stratify authors, articles, journals, and reviewers along their quality, expertise, and prestige. So on average, top-tier journals attract more high-quality submissions from highly reputed scholars and institutions, and they can rely more frequently on experienced reviewers, or reviewers which are eager to put more effort and time in the review process. So the reviewer guidelines is a tool that editors can employ on top of such selection and self-selection process to try to improve and shape the review in a way consistent with this context, namely with the reviewer experience and the journal needs and goals. So we have different types of instructions, as we see before, regarding the gatekeeping, but also the non-gatekeeping, meaning what the reviewer should not consider as a criterion to select an article, developmental instructions, and also whether, especially the gatekeeping instructions, whether they regard the novelty, the validity, or the communication quality of the articles. So we can design some propositions, some expectations about the results, the shape of the reviewer guidelines adopted by journals. Well, first of all, we expect that in lower ranked journals it is more common to use forms instead of text, and vice versa for high ranked journals. In fact, high ranked journals rely on more expert reviewers, which might not like to be constrained by very specific instructions. Well, on the other side, low-ranked journals often rely on less experienced researchers, which might find it useful to have very precise instructions. The second proposition or expectations is that reviewer guidelines of high-ranked journals have a larger number of developmental instructions than low-ranked journals. This is because high-ranked journals may ask greater effort to their reviewers, because reviewing a manuscript for high-ranked journals has a reputational premium, and developmental reviewing is much more demanding than gatekeeping reviewers, because it requires the reviewers to focus on not only spot what is the problem in the manuscript, but also contribute into solving and addressing this problem. But on the other side, high-ranked journals need to preserve the validity of the manuscript, to preserve their high standards. So we expect also that methodological validity is expressed in stricter terms in high-ranked journals, and a difference also in terms of the theoretical and practical contribution, which are expected to be more common respectively on high rank and low rank journals. So to examine this problem, we collected the reviewer guidelines from the journals included in the category of management in the Web of Science, and we found approximately then 1 out of 3-4 have reviewer guidelines. At least what we were able to find. As a proxy of status of a journal, we use the Academic Journal Guide, ranking of journals, which identify 5 layers. 4 stars, which include, for example, journals like the Academy of Management Journal or Administrative Science Quarterly. Then rank 4, 3, 2, and 1. So 4 stars is the higher layer. We coded the text of the reviewer guidelines in 3 steps, and we were in 3 coders. First, we identified general categories of content, then instructions, microcategories, and finally we coded microcategories in terms of whether they pertain to the how of reviewing, so in a gatekeeping or developmental way, and what in terms of validity, novelty, or communication. More detail on the methodology and the data are available in the article. So what we find is support for the first proposition. We see that high-ranked journals mostly use text as reviewer guidelines, while low-ranked journals predominantly employ forms. We observe different types of developmental instructions. Some of them are very generic, so they invite the reviewers to be developmental or to help improve or give suggestions, while some others are more specific, like they ask to identify certain strengths and redeeming qualities, but without a gatekeeping objective, and to help solve problems, weaknesses, and point out solutions and offer suggestions. So what is very striking is indeed a confirmation of our proposition that top journals tend to adopt much more developmental instructions compared to low-ranked journals. So in this picture we see the number of developmental and gatekeeping instructions on the Y and the X axis, and the dots identify the layer. So the black big dots are the 4-star journals, and we see that they all display at least 4 developmental instructions, while low-ranked journals have very few of them. So apparently top journals tend to be more developmental, and they also include a larger number of non-gatekeeping instructions. But they need to preserve the capability to identify impactful works. So these are, seems to be strategies which are consistent with the perceived risk to reject very impactful works if only strong gatekeeping instructions are included or taken into consideration by the reviewers. So overall, we observe these 3 traits in the reviewer guidelines of top journals. They have instructions to be developmental, a lower number of gatekeeping instructions, and more non-gatekeeping instructions. At the same time, they have to preserve high standards of validity. So it is interesting to notice that the instructions to assess the methodology have 2 different verbal content. They can either refer to methodological soundness or rigor, and these are synonymous of logical, solid, scrupulously accurate, precise. So they imply a very high standard of methodological selection. or they can use other wording, whether, for example, the methodology is appropriate, which means suitable or proper in the circumstances, pertinent to the purpose, so they give a more relative conception of methodological quality. Finally, we can use terms like methodology explained clear and adequate, which don't even refer to the validity of the methodology, but only to the quality of the communication. And we see that top journals use much more frequently terms which imply a much stricter definition of the methodology compared to lower ranked outlets. Finally, another important difference regards the emphasis on the theoretical contribution, which is particularly strong in top journals, versus the practical implication. So, some concluding reflections and remarks. So, on one hand, the fact that developmental instructions are only common among very high-ranked journals may appear efficient, because more time and effort are allocated to review contributions that are potentially more valuable. On the other hand, this may represent another example of cumulative advantage in science, which is known as the Matthew effect, meaning that the scientists which are more likely to undergo the peer review process of a top-tier journals and to receive, therefore, more constructive reviewers are scientists with the greatest amount of institutional and personal resources, while peripheral scientists and institutions and systems are more likely to target lower-ranked journals, where reviewers are not expected to be developmental. And this evidence is kind of worrisome if we take into consideration that in recent decades there has been a massive shift of the scientific production to such peripheral and developmental developing countries. For example, in 1996, US and UK produced 63% of the publications in the field of business management accounting, and in 2018 was 25%. So arguably, many good ideas are produced in the periphery of the system, and it is very important to find a way to recover in such important contributions, and in other words, to study ways to expand the developmental functions also in low-ranked journals. I conclude with some readings, and please feel free to contact me at my email address.